Hello, boys and girls and Cougar parents. Let's take a look at Unit 4 study guide. I have a test coming up this Wednesday. I hope you guys are all prepared. The first part of the study guide deals with conversions. We're converting scientific notation to standard form and standard form to scientific notation. Let's do a couple problems together. Let's start with the basics. First of all, in order to have a number in scientific notation, you need to have a coefficient, which is the coefficient has to be 1 or greater, but less than 10. And when I take a look at this coefficient here, that it's a good coefficient, okay? It's 1 or greater, it's less, it's between 1 and 10. Now when I go over here, I see that my coefficient is 53.3. This is too high, it's too large, okay? This is not written in scientific notation. That's bad. No, it's not scientific notation. It does have a base 10 number, which is good. And remember, your exponent can be positive or negative. It just has to be an integer. So this doesn't disqualify it at all. They both have a base 10 number of 10 to the negative third power, which simply means move your decimal point 3 places to the left. Let's take a look at a couple problems from our study guide. On the front page here, go down towards the bottom. On the top of your second and third column, we have two examples here. We have 3.00101 times 10 to the negative third power. Remember, it's our exponent that's in charge of the 3Ds. It's in charge of the decimal. It's in charge of the direction. Since it's negative, that's telling us to go to the left. This negative here is telling me move to the left. And it's also telling me the distance. I have to go 3 place values to the left. So it looked like moving the decimal point 1, 2, and then 3. I have to move it over here. And what I would do is I would fill in these empty spaces with zeros and then put the remaining, digits in place. I don't need a second decimal. Sorry about that. Okay, 0, 1, 0, 1. And there's our answer. If you want to put a 0 here as a placeholder in the ones column, that's fine. But we've got 0.003000101, a very small number. Over here, our next problem, we've got the number 1 in 113 thousandths times 10 to the 6th power. This is telling me to move, once again, our exponent's in charge. It tells the decimal point what direction to move, and since it's positive, I'm going to go to the right. Okay, it's a positive exponent, so it's telling me to move to the right, and the distance is 6 places to the right. So I'm going to go 1, 2, 3, 4, 5, 6. So I moved it 3 places to the right just to get it past the 1, the 1, and the 1, and the 3. And then I had to move it 3 more over. And these empty place values I'm going to fill with zeros. So I'm going to get 1, 1, 3, and then 0, 0, 0. And my number will be 1,113,000. Remember, the exponent that's in the scientific notation, it's in charge of the 3Ds. The decimal, the direction, if it's negative, it's to the left. If it's positive, it's to the right, and the distance. Now we're working backwards. If we go to page 2, we are changing numbers that are in standard form to scientific notation. Now the first step is you need to take this number that's written in standard form and turn it into a coefficient that's legal for scientific notation. So that means this coefficient has to be between 1 and 10. So I'm going to need to move the decimal point between the digits that would give me a proper coefficient, which would be 3.42 or 3 and 42 hundredths. And then we'll have to multiply it by a base 10 number. Now this base 10 number is going to have to kick this coefficient back to its original value, which is 34 and 2/10. And in order to do that, I need to move this decimal point over one place, back between the 4 and 2. So that means I'm going to have to make the exponent 1, and I'm done. It's that simple. So the first step is change your standard form number into a coefficient that's legal. That means you have to make this, use all your non-zero digits to make a number that is between 1 and 10. So you got to move the decimal point to the right place. Now if I would have put it back here after the 2, the number would have been way too large. If I would have put it in front of the 3, it would have been too small. Okay, the only place where I could move it was between the 3 and the 4, which would give me 3 and 42 hundredths, which is between 1 and 10. Let's take a look at our next one. Here I have, looks like I have 5,555 10,000ths. Again, I need to move the decimal point to a place where I'd have a coefficient that would be legal for scientific notation. And the only place where I can move this decimal is between the first two fives here, which give me 5 and 555 thousandths. Okay, that's between 1 and 10. And then I need to multiply it by a base 10 number. And this base 10 number would have to move this decimal point back to its original place, which would be 1 to the left. So that's going to be -1. I have to move it 1 to the left. Let's take a look at our next standard form number. We have, it looks like 4 tenths, hundredths, thousandths, 10,000, hundredths, 4 100,000ths. Okay, that's a small number. Again, I'll need to move my decimal point all the way back here. Okay, I have to move all the way back here because my number, my coefficient, has to be between 1 and 10 again. And now I have to ask myself, okay, I have to move the decimal point then from here all the way back to there. So I'm going to have to move, my base 10 number is going to have to be 1, 2, 3, 4, 5. It's going to have to be -5. I'd have to move this decimal point 5 places to the left to get it back to its original spot. Okay, and likewise, here I've got, hey, this number looks a lot like the number up here. In fact, it is. It's the same number. So I got to make it 5.555 times 10. And in order to get this decimal point back out in front, I'd have to move it 1 to the left. So it'd be to the -1st power. Boys and girls, I want to take a look at one more special example. Here we have 12 and 5/10. This is written in standard form, and I want to write it in scientific notation. So I need to ask myself, where do I need to move this decimal point so that I have a coefficient that would be between 1 and 10? And the only place where I can move it is between the 1 and the 2, which would give me 1 and 25 hundredths. And then I'd have to multiply it by a base 10 number that doesn't get this decimal point to the end over here or end over here. Where do I want to get it? I want to get it back to its original place, which was between the 2 and the 5. So in order to do that, I'd need to move it 1 to the right. Okay? I just want to show this example, and I showed this in class, but I want to make sure you understand that the goal is to take this standard form number, write it in a legal coefficient, okay, a legal coefficient for scientific notation, which means it has to be between 1 and 10. So you got to move the decimal point between the 1 and the 2, which would give me 1 and 25 hundredths. So now I have a legal coefficient here. But then I need to multiply it by a base 10 number that would get that decimal point back to its original place, which was between the 2 and the 5. I hope you understand scientific notation well now. See you tomorrow.